Hello and welcome to this quick video where I'm just going to talk about error intervals and truncating. Now, truncating is when you cut off the rest of a number instead of rounding, so you're not looking at what it's closest to, you just cut it off to the degree of accuracy that you've been told. So if I was going to truncate 2.792 to one decimal place, I'm just going to write down 2.7 because that's my first decimal place. That all just goes away. So truncating 2.792 would be 2.7. Even though it's closer to 2.8, that would be rounding. Here, just 2.7. 316,284 to two significant figures. Well, here I've got my 3 and my 1 as my two significant figures. Everything else is just going to be 0. So if I'm truncating that, that'd be 310,000. So what this means is when we're doing error intervals, it's not quite the same process as if something has been rounded. So here, if x equals 6.2, and that has been truncated to one decimal place, what is my error interval for x? So here, I mean, the smallest value that x could be is, this time, 6.2. It is the number. Anything less than that, and it would have been truncated to a different number. And the biggest value that that can be, well, it can't be 6.3, but anything less than 6.3, so it can't be equal to it, but anything less than 6.3 would be truncated to 6.2 in this range. So we're not taking this value, halving it, adding it on, taking it away. We're just going to say, well, this is the smallest it can be, add on this degree, and that's the biggest it can be. Anything in between here would be truncated to 6.2. Here, 4,370,000 was truncated to three significant figures. Write the error interval for this value. So here, I mean, the smallest value that it could have been is 4,370,000. That would get truncated to three significant figures to 4,370,000. Anything less than that, and it's going to be truncated to a different value. Biggest value that could be then would be 438,123,4. Here again, it can't be this value because this would get truncated to a different value. But anything between this range, not equaling this, would get truncated to this. So for when it's truncated, it's going to be this value, and then here I'm going to have to add on the 10,000. That's effectively what we've rounded it to. This one, this was a past exam question. I think you may have seen it in a mock already, or at least in this style. My calculator display is broken. Hate it when that happens. And just shows the number n as this, 3.21, and then some stuff. This bit's all broken, can't really see it. Write the error interval for this number. Now, it hasn't used the word, but effectively here, we've just truncated it. We've just cut this off. So, as with our other questions, the smallest value it can be, well, it is this number. Maybe that doesn't actually show anything. And here, this is going to be the upper bound for this value. Here, anything less than this can't be equal to it. Anything less than this would round to 3.21 if it had been truncated. Thank you.